Hi, my name is Vishal Gagrai, currently studying Masters in Supply Chain Management at Tilburg University, and I will take you through the details of this project. The project at ASML and Codex is a part of the High-Tech Supply Chain Excellence Program. This is a program which was initiated by ASML in cooperation with Logistic Community Brabant and ASML's first-tier suppliers such as VDL ETG, Nevas, and KMWE. ASML is experiencing an explosive growth in volumes and complexity, which has a big impact on the performance of the suppliers who have to keep up with these challenging growth and quality requirements. Therefore, ASML is striving to achieve operational excellence in supply chain and wants to support its suppliers by setting up an high-tech supply chain excellence educational program and community. With internships performed by university students with different suppliers and ASML, more knowledge is gathered and new innovative ideas can be implemented and shared within the ASML high-tech supply chain excellence community. One of the projects that adds to this high-tech supply chain excellence objective is improving demand visibility in the semiconductor industry. So before talking about the project description, let's talk about Codex, which is a strategic supplier to ASML. Codex is an original design manufacturer and system integrator for gas and fluid transportation. They specialize in designing, manufacturing, cleaning, and testing metal and plastic hoses and hose assemblies, and cater to various industries like semiconductors, energy, aerospace, electromobility, and healthcare. For ASML, they manufacture dedicated build-to-print pre-installs delivered directly to ASML, as well as vendor components and assemblies delivered directly or via other multi-tier suppliers. ASML is experiencing supply issues from Codex, resulting in subsequent delay in production of their machines, often leading to escalations. On further investigation, during the initial interviews with the ASML and Codex teams, it was highlighted that there is a lack of clear, complete, and timely flow of demand-related information from ASML to Codex. This limited visibility gives rise to challenges in capacity planning at Codex, leading to delays in commitments to ASML's growth plans. Against this current background, the problem statement of this research is, how can the flow of information from ASML to Codex be improved, and how can this enhance the quality of inputs for capacity planning at Codex? The two main objectives of this project, as identified through preliminary analysis, are to develop a machine component mapping by creating an overview of all possible demand for Codex products and linking them to machines, cabin tooling, spare parts, and upgrade modules at ASML. The second objective is to develop a forecast accuracy model to assess reliability of forecasts and suggest improvements. The development of these deliverables is based on the design science research methodology. Design science can be described as an outcome-based research methodology which provides guidelines and iterative methods within research projects. Extant literature and industry practices are studied extensively to find already existing tools relevant to the problem at hand. Systems and processes, both at the organizations and under research and also in similar industries, are examined and utilized to reach desired ends. These tools serve as the foundation for the proposed research. In order to define the design requirements, discussions with relevant stakeholders are held. Conditions for applications are set based on inputs from end users and line managers. Relevant stakeholders are also interviewed to evaluate the relevance of the problem at hand. Finally, the developed tools are tested by the end users and necessary refinements are carried out based on their feedback. A mixed method approach is deployed where both qualitative as well as quantitative data are collected and analyzed. While the deliverables explained in the previous slides help us to meet the overall objective of this project, there are a few limitations to this project as well. Data collection and analysis that have been carried out are focused on the current case study between ASML and Codex only. Hence, there is a low generalizability of the current research to other practical settings. There is also a limited future relevance of the proposed solutions due to a continuous technological developments and changes in demand-related information sharing methods and platforms. However, the research methodology that has been adopted in the current project can be replicated to other suppliers in the ASML supply chain to improve their respective demand visibility. Thank you very much for your attention. If you are looking for more information regarding my research, or if you are interested in reading my report, please contact LCB. I want to thank the entire team from LCB, and especially Caroline and Marlu, for taking me on board and introducing me to the ASML High-Tech Supply Chain Program. I would also like to thank all members of the project team from ASML and Codex for the help and support during the project. Finally, I would like to thank my thesis supervisor, Dr. Roland, for his continuous guidance and motivation to make this project a success. Thank you.